These gorgeous dunes are located within an impact crater in Acidalia Planitia, a largely flat plain that is part of Mars's vast northern lowlands. The region spans roughly 3,000 kilometers and sits between the Tharsis volcanic province and Arabia Terra to the north of Valles Marineris, the largest canyon in the solar system. Acidalia Planitia is visible as a dark patch from telescopes on Earth because it is covered in dust and fine materials rather than bright rocky highlands. The region's surface also features tens of thousands of low circular mounds identified as potential mud volcanoes, which are interesting target for researchers. Mud volcanoes are geological structures formed when a mixture of gas, liquid, and fine-grained rock, or mud, is forced to the surface from a distance of several meters to kilometers underground. Scientists are interested in the mud volcanoes because the sediments brought up from below could contain organic materials that might provide evidence for possible past or present microbial life below the Martian surface. Scientists also believe that an ancient ocean or another water body's ice-covered once existed at Acidalia Planitia and other parts of the northern lowlands. Although Mars today is dry, cold, and virtually airless, its surface is carved with unmistakable evidence of a wetter past. Features resembling ancient river valleys, lake beds, and minerals that only form in the presence of water point to long-lived lakes, possibly even shallow seas, that flowed on Mars' surface billions of years ago. For liquid water to persist, however, Mars would have needed a much denser atmosphere to trap heat and sustain higher surface pressure. Understanding when and how that atmosphere vanished is essential to reconstructing Mars' climate evolution and to determining how long the planet may have remained habitable. Over the years, scientists have gathered mounting evidence that solar wind, the constant stream of ionized particles emitted from the sun, and radiation stripped away much of the Martian atmosphere. Among the most significant mechanisms behind this erosion is a process called sputtering, where high-energy particles from solar wind collide with the planet's upper atmosphere. These collisions, in principle, transfer enough energy to neutral atoms and help break them free from the planet's gravitational pull, flinging them into space. Since sputtering is actively lifting and removing molecules from Mars, this process may even have been the driving force behind the loss of Mars's once thick atmosphere, and with it, its ability to host liquid water on the surface. This observation shows part of the ejecta from an impact crater about 6 kilometers in diameter to the west in Utopia Planitia. Utopia Planitia is a large plain within Utopia, the largest recognized impact basin on Mars and in the solar system, with an estimated diameter of 3,300 kilometers. It is also the Martian region where the Viking 2 lander touched down and began exploring on September 3, 1976, and China's Zhurong rover touched down on May 14, 2021, as a part of the Tianwen-1 mission. The ejecta lobes seen here have morphologies suggesting icy flow. Several small, about 100 to 200 meters in diameter, craters on top of those lobes have a distinctive formation. One interpretation is that the impact crater exposed nearly pure water ice, which then sublimated away where exposed by the slopes of the crater, expanding the crater's diameter and producing a scalloped appearance. The small polygons are another indicator of shallow ice. Mount Sharp stands in the middle of Gale Crater, which is 96 miles, 154 kilometers in diameter. The mountain rises about 3 miles or 5 kilometers above the landing target on the crater floor, higher than Mount Rainier above Seattle, though broader and closer. It is not simply a rebound peak from the asteroid impact that excavated Gale Crater. A rebound peak may be at its core, but the mountain displays hundreds of flat-lying geological layers that may be read as chapters in a more complex history billions of years old. Twice as tall as the sequence of colorful bands exposed in Arizona's Grand Canyon, the stack of layers in Mount Sharp results from changing environments in which layers are deposited, younger on top of older, eon after eon, and then partially eroded away. Several craters on Mars contain mounds or mesas that may have formed in ways similar to Mount Sharp, and many other ancient craters remain filled or buried by rock layers. Some examples, including Gale, hold a mound higher than the surrounding crater rim, indicating that the mounds are remnant masses inside once completely filled craters. This presents a puzzle about how environmental conditions on Mars evolved. Conditions that somehow led to sedimentary materials enter this family of craters for a long time and stay. Then, after they hardened into rock, somehow the rock got eroded away and transported out of the craters. While the higher layers may be deposits of wind-blown dust after a great drying out on Mars, some lower layers of Mount Sharp tells of a lake within Gale Crater long ago, or wind-delivered sediments subsequently soaked by groundwater. Orbiters have mapped water telltale minerals in those layers. Presence of liquid water is a sign that conditions favorable for life once existed on the red planet. Currently, Mount Sharp is the only place accessible on Mars where scientists can investigate such incredible transitions in one stratigraphic sequence. These transitions likely occurred billions of years ago, maybe even predating the oldest well-preserved rocks on Earth. Possible explanations for how erosion shaped the mountain after layers were deposited include swirling winds carving away the edges, and perhaps later wet episodes leaving channels down the sides and fresher sediments on the crater floor. Clues about those episodes present Curiosity Rover with other potentially habitable environments to investigate. Since landing on Mars in August 2012, Curiosity has been slowly climbing the mountain with a mission to find evidence of a habitable environment and understand the deep history of the planet.